Let's say you're training a team to use a super expensive piece of industrial machinery, but you only have one. A single mistake could be a disaster. So what do? Well, you build a digital replica, a cyber twin. And today, we're diving into a project that did exactly that for a complex robotic arm. It's a simulator that's not just for training, but for defending our most critical infrastructure from cyber threats.
So, here's our plan. First, we're going to look at the hardware challenge that got this whole thing started. Then, we'll get into the cyber twin solution itself. We'll take a peek inside the simulator, see how it's used for cybersecurity training, and then wrap up by looking at what this all means for the future. Ready? Let's go. You know, every great invention really starts with a problem. And in this case, it was a very real, very physical challenge that made the creators think, okay, we've got to go virtual. Let's look at the piece of hardware that kicked this all off. So the story begins with this thing right here, a real, physical Brasio++ robot arm. The original project, a few years back, was all about controlling this actual device. You can see it all set up, ready to go. And it's a fantastic machine for sure, but it has one big built-in limitation.
And here's that limitation. What happens when you need to train dozens of people at once, or maybe run a huge cybersecurity competition? Buying and setting up tons of these physical arms is just a logistical nightmare. It's expensive, it's complicated, it just doesn't scale. So they needed a completely different way of thinking.
And that new way of thinking is the cyber twin. It's a really brilliant solution that perfectly bridges that gap between the physical world and the digital one. And here it is. This is the answer. It's a lightweight but totally functional 3D software simulation. Now, this isn't just some video or animation. It's a living model that you can control, you can monitor, and you can even attack in a completely safe virtual space. It's built to do everything its physical brother can do. So that brings us to the official definition. What is a cyber twin? It's a software-based cyber-physical simulation system that perfectly mirrors a real-world machine. Think of it like a bridge that connects the virtual world of simulation with the real world of industrial automation. It's a dynamic, living, digital copy.
Okay, so how does it actually work? What's really cool is that the simulator isn't just some random program somebody cooked up. Its entire design is based on a blueprint that's used across the entire industrial world.
What makes this simulator feel so real is that it's built around something called the ISA 95 automation pyramid. That's what you're seeing here. This is the global standard for how industrial control systems are designed. That means this isn't just a toy, it's a faithful recreation of a real operational technology or OT environment, the kind of tech that runs everything from factories to power grids. This project really focuses on the 3 core levels. Down at the bottom, you have level 0, the field level. That's the virtual robot itself. One step up is level 1, the control level. This has a simulated PLC, a programmable logic controller, which is basically the brain of the whole operation. And then at level 2, you have the supervisory layer, which is the HMI, or human-machine interface, where an operator can watch and control everything. Let's zoom in on that first level, level 0. Right here, you get a feel for the direct control you have. The panel gives you individual sliders for every single joint, the base, the shoulder, the elbow, the wrist, all the way to the gripper. It's like you have your hands directly on the virtual machine. And it's not just about moving around, it's about actually interacting with things. The simulator has a physics engine built right in, so the arm can do real-world tasks. You can see it here doing a pick-and-place move, grabbing a cube and putting it somewhere else. It even changes the cube's color to orange when it has a good grip. Pretty neat. For anyone who loves the nitty-gritty details, here's a quick peek under the hood. This table breaks down all 6 axes of control, from the base spinning around to the gripper opening and closing. Every single axis has its own virtual sensor, a virtual motor, and a specific control on the interface, just like you'd find on a real industrial robot. So, we have this unbelievably detailed and realistic simulator, but all this amazing tech serves a really important purpose, and this is where we get to its most powerful use case, getting ready for real-world cyber threats. When you boil it all down, the whole point is this: the simulator is a safe, scalable, and super powerful training ground for operational technology cybersecurity. It creates this controlled sandbox where security pros can learn to defend the systems that run our modern world without any risk of real-world damage. And this isn't just a concept, it's already been put to the test. The system has been used in huge international cybersecurity competitions, like the CSCS 2024 Challenge and the Deutschland's Best Air Hacker 2024 OT Challenge. This is literally where the next generation of cyber defenders are honing their skills. One of the project's own design goals says it perfectly. The mission is to provide a controlled and observable environment for analyzing industrial communication patterns and simulating potential attacks on PLC-HMI interactions. I mean, it's practically built for battle testing our defenses.
Okay, so we've seen the problem, the solution, and the real-world impact. So let's wrap this all up by looking at the bigger picture and what's next for this kind of technology.
So, what are the big things to remember here? First, this cyber twin completely solves the problem of scaling expensive hardware. Second, it gives us a safe sandbox to play in for both development and training. Third, it's built on real industry standards, so it's incredibly realistic. And maybe most importantly, it's a critical tool for training the people who are going to protect our industrial systems.
And that leaves us with one last big question to think about. We've just seen how a physical robot can be mirrored perfectly in a digital world for training and defense. So as this tech gets more and more common, how are powerful simulators like this cyber twin going to change the very way we learn, the way we innovate, and how we protect our most critical systems?